Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this part 18 video from the chapter of Herons Formula, I will be solving set 4 of 5 conceptual problems. These problems are based on the entire concepts of the chapter of Herons Formula. This video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so the first problem says if the breadth of a rectangle is increased by 5 cm, its area increases by 25 cm. If its length is increased by 5 cm, its area increases by 20 cm. Find the area of the rectangle. Okay. So let's say the rectangle, the length and breadth be x and y. X and y. Okay. So we have to find the area of the rectangle. That is, we have to find the value of x into y. X into y. We have to find this value. Okay. Now, so initially the area. The original area is x into y. Now, if the breadth of a rectangle is increased by 5 cm, its area increases by 25 cm square. Okay. So, if the area becomes is increased by if the breadth increased by 5 cm, we have breadth becomes x plus 5 and the area becomes x plus 5 multiplied by y. So, this should be equal to the original area plus 25 centimeter square. So, this should be equal to a plus 25 which is equal to xy plus 25. This implies if you expand the left hand side, we get xy plus 5y is equal to xy plus 25. Xy cancels out. So, we clearly get the value of y. Y is equal to 25 divided by 5, which is 5. Okay. Now, we do not know the original area. So, now we have to find the value of x. So, from the second information, that is, if the length is increased by 5 cm, its area increases by 20 cm square. So, when the length is increased by 5 cm, the area becomes x multiplied by y plus 5, and now the area should be 20 centimeter square more than the original area, that is a plus 20, which is equal to xy plus 20. If I expand the left hand side, I have xy plus 5x is equal to xy plus 20. xy cancels out from both the sides, and we have we can find the value of x as 20 by 5, which is 4. So, x is equal to 4, that is, and y is equal to 5. So, breadth is 4 and length is 5. So, this implies area is equal to x into y, which is 4 into 5, which is 20 centimeter square. So, the area of the rectangle is 20 centimeter square. So, the correct choice is A. Now, as I always say, if I am doing any kind of silly mistake, calculation mistake, and coming up with wrong answer, then please feel free to let me know in the comment section. Or if you do not understand any steps, any concepts I am applying, or if you think I am applying concepts incorrectly or incorrect concepts, then also please let me know in the comment section. I will appreciate that, and I will do my best to address your query. Let's see the next problem. Question number 2. A parallelogram has two of its adjacent sides measuring 13 centimeter each. Find the sum of the squares of its diagonals. Okay. Now, so let's say this is the parallelogram. So the adjacent sides are equal. Okay. Let's say. So, if let's say these two are the adjacent sides, equal adjacent sides of 13 centimeter each. So, the parallelogram must be Now if the two adjacent sides of a parallelogram are equal, it is a rhombus. This is the catch of this problem. So if we have 13 centimeter, these two are adjacent sides 13 centimeter, then obviously the side, so let's say ABCD is the parallelogram, then obviously DC will be equal to the opposite parallel sides AB, which is 13, and also AD will be equal to the length of AD, side AD will be equal to the length of its opposite parallel sides BC, which is 13. So clearly we see that all the sides, length of all the sides are equal. So a parallelogram whose length of all the sides, all the four sides are equal, is a rhombus. And we know, okay, so it is a rhombus. Now that we know it is a rhombus, what is the relation between the length of the diagonals of a rhombus and the length of each side? If the length, let's say, these are the diagonals AC and BD. If the length of the diagonal AC is D1 and the length of the diagonal BD is D2, this relation it is obtained from the Pythagoras theorem from the triangle AOD. In right angle triangle AOD, applying Pythagoras theorem, you will get that for this problem you will get 13 square, that is the length of each side, square is equal to D1 square plus D2 square plus divided by 4. That is, for in a rhombus, the length, the square of the length of each side is equal to the sum of the squares of the diagonals divided by 4. Okay, so what is 13 square? 13 square I think is 169. So this implies that D1 square plus D2 square is the sum of the squares of the diagonals. This will be equal to 169 multiplied by 4, which is 36, 24, 27, 676. So the correct choice is C. C is the correct choice. Let's see the next problem. Question number 3. The perimeter of a rectangle is a 2-digit number whose units digit and the tens digit represent the length and breadth of the rectangle respectively. Find its area. Okay, so let's say the 2-digit number is AB. If I consider the 2-digit number is AB, then obviously the rectangle is it is given that the units digit represents the length. So this is B, and then the breadth is A. Okay. The perimeter of a rectangle is a 2-digit number. Now if the 2-digit number, if we consider as A and B, then obviously the rectangle will have A and B are digits obviously, and they are obviously non-zero because the length of the sides of a rectangle it cannot be 0. So B is the length of the side, B is the length and A is the breadth. So what is the perimeter of this rectangle? This is equal to 2 into A plus B. The perimeter of a rectangle is a 2-digit number. So we see that the number is AB. AB is equal to the perimeter 2 into A plus B. Okay. Find its area. Find its area. Okay. From this fact. Okay. Now, sorry. AB. Now what? AB is the 2-digit number. So what is AB? If I expand the number in the expanded form, this is 10A plus B. The actual number, the value of the 2-digit number AB in the expanded form is 10A plus B. So I have not AB equals to, but 10A. I see 10A plus B is equal to twice A plus 2 into A plus B. So this implies that the perimeter number whose units digit and tens digit represent the length and breadth of the rectangle. So what do we get from here? From here I will get, so 10A plus B is equal to twice A plus twice B. So this implies I will have 8A is equal to B. find its area. So area will be A into B. We are having 8A is equal to B. A into B. The perimeter of a rectangle is a 2-digit number whose units digit and tens digit represent the length and breadth of the rectangle. So if I consider the number 2-digit number to be AB, then B should represent the length and A should represent the width. Area is A into B, so we have to find the value of AB. Area is AB. So how do we find the value of AB? Now it is given that the perimeter is the 2-digit number. Now the 2-digit number is in the expanded form is 10A plus B. 10A plus B. Also the perimeter of this rectangle having length B and width A is 2 into A plus B. So we are having 10A plus B is equal to 2A plus twice B, and from here we are having 8A is equal to B. From this fact, how do we find the value of AB? The answer is 8 centimeter square. The perimeter of a rectangle is a 2-digit number whose units digit and 10 digit represent the length and breadth of the rectangle. Perimeter rectangle. Find its area. Area is A into B. The only relation we are getting between the A and B is 8A equals to B. I don't know how can we find the value of AB. Just from this fact that 8A is equal to B, how do we find the value of AB? I don't know. I'm sorry I couldn't solve this problem. If you can solve this problem, then please do let me know in the comment section. I will appreciate that. But I will give a little a few more moments to see if I can solve it. The perimeter of a rectangle is a 2-digit number whose units digit and the tens digit represent the length and breadth of the rectangle. Okay, so if the 2-digit number is AB, then B is the length and A is the breadth. Okay, so the area is AB and the perimeter is 2 into A plus B. Okay, and the number in the expanded form is 10A plus B. So 10A plus B is equal to 2 into A plus B. So from this equation we get 8A is equal to B. From 8A equals to B, how do we find the value of AB? We need the value of AB. AB. 8A equals to B. 8A. 18. Sorry, I don't know. Maybe I don't know. Maybe it is also possible that I have incorrectly copied the problem. Maybe the problem was something else. Anyway, I'm sorry for this. But if you can solve this problem, if you think that the problem is correct, I couldn't solve it, then please let me know. I will appreciate that. Question number 4. In a right-angled triangle ABC, AB is equal to AC. Now, if it is given that in a triangle ABC, AB is equal to AC. In a right-angled triangle, if two sides are equal, those two sides has to be the two arms. So if in a triangle AB is equal to AC, then obviously we will have since the common vertex is A, then A must be the right angle, A must be the 90 degree, the angle A must be 90 degree. So the triangle must be A, B and C. So these two are the perpendicular arms and they are equal. So AB is equal to AC and this is 90 degree. Okay, so the general convention, the ratio A is to B is to C over here, A, small a, denotes the length of the side opposite to the vertex A, that is BC. BC, the length of BC is A. Similarly, the length of AB is small c and the length of AC is small b. So we are asked to find the ratio of the length of the sides of the triangle. Okay. Now this is the right angle triangle. This is the right angle isosceles triangle. So obviously we will have B is equal to C. Let's say B is equal to C. Let's say it is K. Then and also we will have A square. Applying Pythagoras theorem, BC is the hypotenuse and AC and AB are the two arms. So I will have A square is equal to B square plus C square, which is equal to K square plus K square, which is equal to twice K square. So this implies A is equal to square root of 2 into K. So this implies then A is to B is to C is equal to A is square root of 2 into K. B and C are equal, they are K is to K, which is equal to, if I divide all the parts in a ratio of multiple parts, I can divide all the parts or multiply all the parts by the same non-zero number and the ratio remains the same. So if I, in this ratio, if I divide all the parts by K is obviously a non-zero number, then it will remain the same. So this becomes square root of 2 is to 1 is to 1. Okay. Let's see the next problem, the last problem. The numerical value of product of the lengths of the sides of a triangle is 512 units. Find the minimum possible perimeter of the triangle. Minimum possible perimeter of the triangle. So let's say this is in general a triangle ABC. The triangle BBC. So the length of the sides are A, B and C. It is given that the numerical value of the product of the lengths of the sides of a triangle is 512 units. So it is given ABC is equal to 512. Now we have to find the possible values of A, B and C so that the perimeter is minimum. Perimeter is A plus B plus C. Perimeter is minimum. Now how can we then find the value of A, B and C such that ABC is equal to 512 but the sum of A, B and C is minimum. So the idea is that now it is sometimes the choices will help you. So let's see, but also remember that in a triangle this property, so what we will try to do is that when you will try to when you will try to think of different values of A, B and C such that ABC is equal to 512, you must keep in mind that the sum of the length of two sides of a triangle is always greater than the third side. So A plus B must be greater than C, B plus C must be greater than A and A plus C must be greater than B. So instead of solving the problem directly, I will use the choices as hints. So let's say choice A. Now before that it is saying that find the minimum possible perimeter of the triangle. So let's say in the given choices the minimum is 18. So let's see if we can find the value of A, B and C such that ABC is 512 and A plus B plus C is 18. A plus B plus C is 18 and ABC is 512 and also these three conditions are met. Okay. So ABC. Okay. Now what values we can think of A, B and C so that A plus B plus C is 18, and ABC is 512. Mm, mm, okay. Or should we try to factorize the ABC? We should be try to factorize 512, express 512 as 3 factors, and the factors will be actually the values of A, B and C, and then we will add them up to see the minimum. So 512 is, let's see, 512 is 256 multiplied by 2. This is equal to 128 multiplied by 2 multiplied by 2. Now obviously we cannot this will not so the ABC cannot be 128, 2 and 2, because 2 plus 2 is not greater than 128. So let's see, we have to think of factorize. We have to basically consider express 512 as product of 3 numbers, so that which will be the values of A, B and C, so that their sum is a minimum, and as well as we have A plus B greater than C, B plus C greater than A, and A plus C greater than B. Okay, 128 is 64 into 2, 64 into 2 into 2 into 2. 64 can be factorized as 4 into 4, and then we have, let's say, 8. Now 16, okay. 16 multiplied by 4 multiplied by 8. This will not work, because 8 plus 4 is 12. It is not greater than 16. Okay. 4. Okay. 32. 64 into 8. 64 into 8. Okay. 16, 4. No. 16, 8 into 8 into how about 8 into 8 into 32. This will also not work, because 8 plus 8 is not greater than 32. (18) 8 plus 2, 8 plus 2, 16, 24. 64 into 8. Okay. So this is 64 into 8. Okay, 64 into 8. 64 into this will be 8. So so if so 512 is 8 into 8 into 8. Now can we consider 8, 8, 8, 8? I mean, if the values of A, B and C as 8, which will become an equilateral triangle. Now let's see. The product is obviously definitely 512. Their sum is coming out to be 24, which is there as choice B, and obviously we will have 8 plus 8 is obviously greater than 8. Now this is a choice. One possibility is that it will be an equilateral triangle having the length of each side as 8 units. Now can we think of the sides of a triangle? Can we think of the values of the A, B and C so that the perimeter is less than 24? Less than 24, is it possible? I don't think so. uh, uh, mm, so so I think the answer should be 24. I'm quite sure the answer will be the choice B, but I'm trying to think whether mm, mm, whether the values of A, B, and C can be such that their perimeter is less than 24. The sum is less than 24. So 512 is 64 into 8. This can be, I mean, can we even factorize 512 as product of three numbers whose sum will be less than 24? I don't think so. Anyway, I won't think much. I think the answer should be choice B, that is the minimum possible perimeter of the triangle is 24, and in that case the length of each sides of the triangles will be 8 units. It will be an equilateral triangle. Let me know if I am correct or wrong. I will appreciate that. And if you have any query regarding any concept that I have applied in solving this problem, or if you have any specific doubt or questions regarding this chapter Herons formula, then also please do let me know. I will do my best to help you out. So that is all for this video. If this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So please stay tuned for more sets of solving 5 problems from this chapter. I'm ending the video here. Thanks for watching, and until the next video, take care and bye.